So today we are going to discuss collisions in two dimensions. And in our last topic we have discussed collisions in one dimensions. One common type of non-head-on collision. So this time this is non-head-on collision is that in which a moving object called the projectile strikes a second object initially at rest. So the target ball we are going to consider at rest and the incident ball is moving towards the target ball. This is common situation in games such as billiards and pool and for the experiment in atomic and nuclear physics. So suppose we are considering having ball incident ball having mass m1, velocity u1, and this is our target ball having mass m2 and velocity is u2, but this ball is at rest. So the ball m1 is moving towards ball m2. After some time they collide, and this time we have non-head-on collision. And so after collisions the m1 is moving towards this side with new velocity v1, and definitely v1 should be smaller than u1 because this ball share velocity with the target ball, and while the target ball scattered to this side with mass m2 and velocity v2. So this is our incident target, and after collision this is our incident after collision, and this one is our target ball after collision. As we know that this is 2D, two dimension one, this is y and this is our x-axis here. Now if suppose any vector is between x and y, how we are going to simplify that one? If this is velocity vector, displacement vector, force vector, then if this angle is theta here, so we can say this is our horizontal component and we can say this is our vertical component. Based on that we can use mathematics to simplify this. So same over here, momentum is vector and that is between x and y. So then this is our, suppose this angle is theta 1 and this angle is theta 2. The incident ball angle is theta 1 and the scattered one, the target ball angle is theta 2. So then we can resolve the component of this momentum. This is our horizontal component for incident one, m1 v1 cosine theta 1, and this one is m1 v1 sine theta 1. Similarly for the target ball, this is our horizontal component for the target one and this is our vertical component for that. This equal m2 v2 cosine theta 2, m2 v2 sine theta 2. So this is our diagram. Now we are going to simplify this for conservation of momentum. So we are going to apply the conservation of momentum here. But this is 2D. So first we are going to consider along x-axis. First along x-axis. So momentum before collision equal momentum after collision. So momentum before collision is the incident ball having mass m1, velocity u1, and the target ball is at rest, so the momentum of that is 0. So this is our momentum before collision along x-axis. Now after, we have m1 v1 cosine theta 1 and m2 v2 cosine theta 2. Both vectors are towards right, so we can consider m1 v1 cosine theta 1 plus. Why? Because both vectors are towards right. m2 v2 cosine theta 2. So this is our equation 1 for conservation of momentum along x-axis. Now we are going to simplify it for y-axis. For y-axis, if you can see here, as both the objects are moving along x before, so it's mean our momentum before collision along y-axis is 0. But after collisions, we have the component, the vertical component for both. One is up, one is down based on resultant direction. This is positive, this is negative. So m1 v1 sine theta 1, and down I am considering m2 v2 sine theta 2 with negative sign, because momentum is vector, so upward is positive and downward is negative. So we can write it as m1 v1 sine theta 1 equal m2 v2 sine theta 2. So this is our equation 2. So this is your mathematics for collision in 2 dimensions. But if suppose examiner will give you the situation along y-axis before collision, this is your incident ball, this is our target ball, and this ball is moving toward the incident one with velocity u1, mass m1, m2 velocity u2 is 0, and after that, if one is going toward this is suppose the target one and the incident one is going this way. So then we can simplify this based on these equations, and we can consider along y-axis before collision. This time we have, while the momentum before collision along y-axis is 0 for that. The situation is same, just you need to resolve the component for this. If suppose here you are considering this one is going here angle theta 1, this is theta 2, and then you can consider this is theta 1 dash, and here you can say theta 2 dash, and based on that you can resolve the component. This is vertical component, this is horizontal, vertical, horizontal. Based on that you can simplify your question. And if you are going to apply the conservation of kinetic energy, you can write the equation for conservation of kinetic energy also. That's all for this topic here. If you have any question, feel free to contact me.